So hello guys, welcome to the video. So in this video I will explain you about the question max stack. So let me take you to the editor and I will explain you about the question first. So what's the question? I have given some commands here. Alright. So I will first create a stack here. Then I have to obey the commands. And by that only I have to push pop, top, max. I will explain you everything. So there are 5 types of command. Let me write this first. So first is push, pop, top, and now some new commands like pop, max, and peak max. I guess if you have heard about these commands, right? So I will explain you what these commands do. So first what we will do, we will obey the commands and we will implement it in our stack. All right, so what we will do, we will push 5 inside it. So we all know push 5 means we have to push a 5 number in stack. All right, push this 5 inside my stack. Then I have to push 1. All right, then I have to push 5. All right, so this is done, this is done, this is done. So what I have pushed after it? 5. I have pushed 1, I have pushed 5. All right, so now what will I do? If they have told me to do top, it means peak in our Java. So top means peak and top element means the top element which is at the top of the stack. All right, so the top of the stack we have this element, so this is the top of it. All right, so we did not want to pop it out, we just want to return it. All right, so I will return the top of the stack. So what I will return? 5, because 5 is at the top of the stack. All right, so now we going for the next command, pop max. So now, yeah, so these 3 were regular commands, you all know about these 3 commands, but what is pop max? So pop max will pop the maximum value inside the stack. All right, pop max will pop the maximum value which is inside our stack. All right, so inside the stack, this is our maximum value and this is our maximum value, but the value which is filled afterwards is popped first. All right, this is only happen in the stack only. So I have filled this value afterwards, so I will pop this value first. All right, this happened, so I popped and returned 5. All right, now again top. So top of the stack is 1 now. Top of the stack is 1 now. Now peak of the peak max. All right, so you also not heard about peak max. So what is peak max? Peak max is the value which is at the top and the maximum. All right, the value which is at the value which is maximum inside the stack and is at top, we have to return that only. So in this case we just have 2 values and 1 is smaller than 5 and 5 is greater, so we will return 5 because this is maximum value and it is at the peak of the stack. All right, it is not at the peak of the stack, but if we see from downwards, it is on a certain level from upwards in the stack. All right, so I will return this 5 here. Then so this peak max is done, then I will pop it out. What will I pop? The maximum value which is stored inside the stack, the value which was on the top, right, that I will pop out. So I will pop this out. All right, then I have to return top value. So what I popped 1 out. Then I have to return the value which is at the top of stack. The top of the stack is 5. Done. All right, so now it's done. Okay, so I hope you understood this, why we are doing this, because we have to implement these all operations inside a stack, but without using a stack, I have to create a data structure which behaves like stack. All right, I hope you understood this. I have to create a data structure which behaves like stack, and when I will give push, pop, top operation and pop max and peak max, it should respond accordingly. All right, so now what we can do, if we can create a array, what do you think? Can we create an array? So let's check it. So let me create an array first. For better understanding, I will create it vertically only. Alright, so now I will push 5. So I will push at 0 index, push 5 at 0 index. Alright, now I will push 1 at first index. Now I will push 5 at second index. Right, 0, 1, 2 index. Now what is the top of the array? The top of the array is 5. So I will return 5. So in this case, we can do that the value which is filled at the last is our top of the array. So I will return that value only. All right. So these three cases are done. This case is also done. So now I have to pop the maximum value, right? So I will first find and iterate in the array and see what is the maximum value of the array. All right. So the maximum value inside this array is 5. All right. Then which value is at the top of the stack now? The value which is at the top of the stack is 1. So I will return 1. So now which value is at the peak max? Alright. So the value which is at the peak max is 5. So I have to return this. But now what will happen in this scenario? Not in this scenario. Let's take the example. Let's create a big array. 2, 3, 8, 7, 5, 2. Alright. I can imagine that this is also an example. And for this example, inside this array, if I call a peep max function, or not peak max, let's take pop max only. Alright, if I call pop max function, so what will it do? It will first find and delete the maximum character. So in this, the maximum character is at this position. At 8 is the maximum character, and I have to pop this out. So when I will pop this out, what will happen? That this space becomes empty. Alright. So whenever I will traverse from upwards, I have to always skip this space and then I have to traverse further. And if in some cases it happens that more than one value or two values are traversed or deleted between the elements, so we have to skip a lot of elements and then traverse further. Alright. So this will increase the complexity and this will increase the complexity of code also. So we can't use array inside this. Alright, we can't use array inside this. So I hope you understood it till now. So now can I create one more type of data structure? I will delete this all and I will try to create one more type of data structure, which is, if you have studied the min stack question, we have used it. Inside it, we create two stacks, one for original data, one for maximum data. We will create this for only this question. All right. And what we'll do, when I will push a data inside it, the maximum value in our stack is till now 5. So I will push 5 also inside it. When I will push 1 inside it, the maximum value in our stack is 5 only. 5 is kept here also. When I will push 5 again inside it, So now also the maximum value is 5 only, so I will put it inside the another stack. Then when I will get asked of top, so I will return 5. This is the top. All right. When I will be asked to pop max out, so let this example, let's not use this example. Let's first input some solutions. Let's input 6. So what is the maximum value of this stack now? 6. So I will use 6 here. Let's enter 4. So this max stack is still now 6 only, because 6 is greater than all the elements. So the maximum stack is not updated. Maximum stack is updated with 6 only. Now I will enter 8. Push 8 inside it. So the maximum stack will also become 8. Now I will push every element which is smaller than 8. Then also 8 is maximum value of it. So I will input 8 only. Alright. And then 3. Then also my maximum stack value is 8 only. Alright. I hope you understood now. So now what will happen if we create these two stacks? If I delete a element from it, like if we want to delete a pop max, so for example take pop max, if I delete this value, because 8 was the maximum value, so what I have to do above this, above the element which I deleted, I have to change every value of max stack and modify the value with 6 only. So this is left 6, 6 and 6. Alright. So this is the only problem. I will not write this. This is the only problem in creating a max stack. That, for example, if I take another example, if I delete 6 from here, alright, so I have to delete all this 6 from the max stack, because now the maximum element of our stack is something else. So I have to write 5, 5, 5 everywhere. Alright. So every time a element is deleted, I have to iterate full max stack and then check the condition. Then I have to increase the value. First delete the values, original old values, and then modify the values. Alright. So this is a very bad solution for finding a max stack. So I will also not use this. So I assume that till now you have studied, till now you have understood everything, whatever I have told you. Alright. So now what we can do? We can create a data structure in which we want deletion at of n. Right? We need optimized deletion. So what we can do? Can we create a doubly linked list? And I will create some nodes. Let's see it. Let's take some operation: push, pop, pop, push, push. Right. So these are the operations. Let me write only 3 of them: push, pop, and top. Alright. So I will keep some elements here: 2, 1, say 3, 1, 2, 4. Alright. So if I pushed it, I pushed all the elements. If I want to delete a random element from between, let's say if I want to delete 3. So is deletion easy in this doubly linked list? So yes, deletion is easy in this doubly linked list. It will directly go on 3 and delete this value and connect this node to another. Alright. So deletion is easy in doubly linked list. That's why we have some preferences for doubly linked list, and for it I can also create a tree, or let's say we can create a max heap. Let me show you how. Max heap is inside max heap, greater element is on the top, Smaller elements are on the left and right. Smaller is on the left and greater is on the side. Sorry. I've written then 2, then 1, then I can't take it. 1 and this is also 1. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yes. We have left with one element. Yeah, we have left with 2. I will write my 2 here. Can't write 2 here. I can write my 2 here. Alright. So what's it? Now, for example, if I delete 4, alright, it's very easy to get 4 from here because if we want to delete a pop max, if you want to run this condition, pop max, if you want to follow this instruction in this, so what will I do? I will just go on the root node and take the root node and I will delete it. And when I will delete my root node, so what will happen? Automatically 3 will come here because we have to put the greatest element on the top of root node. Alright. And that's how Max Heap works. Alright. So then this tree is look like this only. Alright. So now what we can do, we can just take an element from this Max Heap, go and search inside the linked list and delete that element. Very simple. Because we needed maximum ordering and maximum searching, and for maximum searching we can use this BST. For maximum ordering we can use this Doubly linked list. Alright, because our question's length is dependent on these two perspectives only. If we have the maximum ordering, so if we can access it fastly, alright, if we can if we can access it fastly, so our optimization will be get more, because in this if I go and delete one element, it takes the time of O of n. Alright, that simple. And if I search any element in my BST, it takes the time of O of 1 only, because we just have to take the root node, but then I have to also order it. Alright, so if for example if it is 4 5 4 3 5 6, not 6 8 6, alright, so if I delete 5 from here, so I have to create the root as 8, then it's left on the 6 and then 4 is connected with it, right? So it's better to see in binary search tree. Alright, so now what next? So now what we will do, if we have this all, let me delete this first, let me erase this all, and if we had doubly linked list and we were using BST, so what we will do, if we have doubly linked list, let me create an example, or let's create this example only, 5 1 5. Alright, so inside doubly linked list, if I create a binary search tree BST for this, so how can I create 1 5? But instead of keeping an element inside this, can I just keep the data and a array list inside it? Can I keep a data and array list inside it? If I can keep a data and this array list, And what will this array list store? This array list will store the address of these nodes, where you are keeping these nodes. All right. So for example, if I have 5, then we can keep in array list, let's example for, let's say 2k, 3k, 4k. All right. So we can keep that 5 is on 2k and 4k. So I can keep this addresses also of my every node. All right. So this will also help us. So let's delete this. I'll show you how will it work. Let me take an example of let's take it 1, 3, 2, 1, and let's take it 4. So why we were doing this? Because we also want maximum ordering. We were getting maximum searching, but we were not getting the maximum ordering. So this is our way to get a maximum ordering. We have to just achieve these 3 things. All right. So what we will do now? I will create. Can I create a data structure type in which we can place the value in front? For example, if I am creating array list, let's first talk about that only. All right. So we will not add our ways, and let's first talk about that only. So I will create my data, and then inside array list, let me give this some addresses, 8k. So I will keep my 1 on 4k, then 3 with 5k. All right. Then 2 will come. So 2 is stored on the address of 6k. 1 is again stored on the address of 7k. So what we have to do, if there are 2 same nodes, so we will not again create a separate node for it. All right. We will just update our address on it. So inside this array list, we know that we have 1 kept on these 2 addresses, 4k also and 7k also. And after that, if I talk about 4, so 4 is kept on 8k. So now this type of data is better for us. Why it is better for us? For example, if you want to pop 1 out, right? So what we will do, we will go and search where is 1. Go and search for the key, and here we get 1. So now we will search that on which address 1 came last. So when first came on here, and then second time came on this address. So at the last, when we put 1, when we pushed 1, we have to delete that address which we pushed at the last. So we pushed 1 at 7k. All right, we pushed 1 at 7k. So what we will do, we will go on 7k address and delete that node. All right. And then also I have to delete that address from our array list also, so that we can update our values. All right. So now what? Sorry. All right. So if I want to pop 3 out, so what will I do? I will go and check where is 3. If I get 3, I will check the address of 3. I will check the last pushed address of 3. So the last pushed address of 3 is 5k. So I will go on 5k and delete it. All right. Simple. And then I have to delete this address also. And when all addresses are deleted, So do not forget to delete this element from our BST also, because if you do not delete this element, so it will harm the order. All right, so order is now correctly, because we have deleted 3, and 3 was only one time inside our list, so we have to also delete that element. All right, now we will check for 2. So now we have to delete 2 from it. So I will find 2, then I will go to 6k, and then I will delete this 6k address. Delete 2 from here. Now I will delete this element also from our stack. Alright, very simple. So when 4 came, I will go at the address of 8k and delete it again. And then delete this element also. Alright, so this is the better way to get the elements and delete the elements. And if I delete by this way, my complexity will be of sorry, I can delete all the elements in, so inside log of n. Alright, so this will be the time complexity of deletion inside this type of list and BST. Alright, so now what we will do further. So now let's take a example for this input only, then I will explain you further. I think this example will work more efficiently for this, because you will understand everything, because we have already used this example. So now what will I do? I will create a list and push my 5 inside it also. So this is our linked list and this is our BST. So I will create my node and then push inside it. Then I will again push 1 inside it. So when I push 5 inside it, what will I do here? I will get my data, and in front of my data I will create my array list, inside which I will store the address. So 4k is the address of this, 5k is the address of this. So what will I do? I will update the value as 1 and store its address also. Then I have to push 5 again. So what will I do? I will create a new 5 element, or I will update in this only. Yes, I will update my address in this data only. All right, now what I have to do? I have to give the top element. All right, so what element is at the top, which has the maximum address, which is the latest address pushed inside our list. So the latest address which is pushed inside our list is 6k. So I will return the value at 6k. I will go at 6k, then I will fetch the value and return at the top. All right, very simple. Then we have the condition of pop max. So how I will pop max? I will first get the maximum value from BST. BST will give us the maximum value, and then I will delete the last occurrence of that element inside our list. So what is the maximum element of maximum element in my BST? 5, and the last occurrence of 5 inside our list is 6k. So what I have to delete? 6k. At 6k address, I have to go and delete my node. All right, so I will delete the address also. Simple. Now I think you are more crystal clear. All right, so after deleting, I will also return it. So now what is at the top? So we will see which address was pushed to the latest one. So the latest address which was pushed was 5k. So I will go at 5k, fetch the value at 5k and return the value. Then I have to peak max. So what will I do? I will get the maximum value from BST only. Maximum value from BST only. And then I have to return it. Then I will see first the address of it, which is at the last occurrence. So last occurrence address was 4K only, and it is the maximum value. So I have to go at that address 4K and then return the value. Simple. Then pop. Then how will I pop? The last occurrence, which is at the top, will pop first. Then I will pop, and what is popped? 1. And the value which is at the top is left with 5 only. Alright. I hope you understood this now and you got an idea what we are doing here. So for this functionality, what we use, we can't take doubly linked list, because doubly linked list do not allow us to access nodes. Alright, doubly linked list do not allow to access nodes. It is behind the backend of that linked list, so we can't access the nodes here. So for this, we can't use doubly linked list. We have to create our custom linked list. Alright, so we will create our custom linked list and then we will solve the question. And one more thing, we need one more thing, that we were using BST. So for this, BST can't be used because we have to keep data and array list both inside our BST nodes. So for this, we can use a functionality which is called tree map. So by name also you can understand, by tree map it will give us a tree which will give us maximum and minimum of this tree, and by map you can understand that it will give us some space for keys and values, so we can place our key as data and then values as in our array list, in which we will put our addresses. All right, so we will understand this. I will create this tree map and then I will show you. Right, so we will create a custom linked list and then we will create a tree map and then store keys and values. And inside tree map we have some functionalities that are some contains one is contains key, so that we can contain the key of this value. All right, then I have the functionality of get, so we can get the value or get the key of it. Then I have the functionality of put also, which I can put key and value. And when we add inside a stack, so what we do, we add everything from last. So add last, so we need add last function, and in this tree map we have a functionality called last key, so we can remove and add both by using last key. All right, so I have explained you the functionalities of tree map, and so we will go and code this out. So we will code this on Nados. All right, so here is our function given, max stack. So first, what will I do? I will create a class node. Inside this class node, what I have to store? One data. Let's take it x. One next, and one previous, because we will create a linked list, so we will need it. Then I will call the constructor for it and assign the value to x is x only. All right. So now what we will do? I will create a node head and initialize it -1 and a node tail, because we are creating our custom linked list, so we will need this all, head and tail both. Right. And as we have talked, we have to create a tree map of one type of data, integer, and second type is of array list, so that we can store our value, and array list will store nodes. And name of, let's say, take a t map only, sorry, t map. Then I will create my constructor max stack for this class. And what will I do inside it? I will just initialize my t map, tree map, which is named as t map here. And secondly, I will add the value of head.next as my tail and tail.previous as head. All right. So now I will write the function for push. So what we have to push? When we get an element written as push, so we will push that value inside our linked list and update the value in that tree map also. So what will I do first? I will create a node, because obviously I have to create a new node and I am creating my custom linked list. So obviously I have to create a new node, and every time I create a new node I have to pass the value x. All right, as I have passed here also. All right. So now what? I will call my add node function, which it will add this node. I will check some condition that if that key is already exist inside our tree map, so I have to update the address of that. Okay, not update, I will have to add the address inside that. And first I will create the array list, and then I will update it. tmap dot add that node. Sorry, I have to not add the node, I have to put it the x and temp. I have to put the value, and at that value, at that key, I have to put the value as temp, which is our array list. All right, and inside my array list, if it is not there, if it does not exist there, so I have to create a new box, separate box for it, and then add my node inside it, and then put the value tmap dot put the value inside it is x and temp, key and value both. All right, so this completed our push function. So I hope you understood what we did inside push function, because I have explained line by line. Now comes the turn of pop function. So for pop function, similarly, I will create a node which is at tail dot previous, because I have to pop from last. So I have to come at the tail dot previous node. Then I will fetch the array list and get the value from tmap. Then create my variable inside which I will get the size of my array list. Size. And then I will decrement it by 1, because if we had that key inside that, obviously we have that key because it is already inside the stack and we have to pop it out. So obviously it was inside the tree map. So I have to get the size of the array list of that array list of that key, and then minus it by 1 so that the last address should get subtracted. And then I will check that what I told you, if the array list gets empty, I have to delete my value also, key also. I will check that if my array list is empty now, so I will remove that node only, because without checking we can't remove our node, because if there is possible condition that we have same elements on different addresses, so I have to pop the latest address. I have to pop the latest address one. All right, that's why I have subtracted one. All right, so I will remove by writing temp dot remove dot node x. Then I will delete that node also. All right, and then return my node dot x, and I popped out. All right, so this was my pop function completed. Now what I have to do, I have to write my top function. So what is inside my top function? I have to return the value which is at the top of the stack. All right, so the value which is at the top of the stack is very simple. I just have to return our value of tail dot previous and dot x. So this will return the element which is at the top of the stack. All right, it's very simple. We just have to write one line and return this. Similarly for peak max also, I just have to return our array list dot last key, means the last value. All right, so I have to return the array list's last value. So I will write my name of array list and then last key. All right, now come the pop max function. In this we have to write a lot code. No, in this also we just have to return our last key. All right, obviously not. We have to write a code for pop max, because firstly we have to find the maximum element, then we have to pop it. So what will I do? I will create a array list of node temp, then I will get the value from my tmap of the last value, the last key function using, then I put my semicolon. Then I will write create a node to be deleted, let's say, because this node will get deleted. So I will get the value of this node which I have to remove, and I will decrease the size of my array list also. All right, and what will I do? One condition, if my temp dot size, as I have checked before also, it gets 0, So I will remove that node also from it. So to be deleted dot x will get removed from it. All right. Now I will call delete node function. Inside that I will pass the node which is to be deleted, and I will return my to be deleted dot x. That means it will get the value to be deleted and get the value of that node which was at the to be deleted dot x. All right. So this completed my pop max function. Now